Hello everyone, July 26th. Alright, let's do this. Hopefully we can do it fast because I want to do this one again. You're given two zero-indexed strings, source and target, both of length n, source and target, and consisting of lowercase English letters. You're also given two zero-indexed characters, array original and changed, and an integer array cost, where cost I represents the cost of changing the character original to the character I. So it's a graph with weights. You start with the string source. In one operation, you can pick a character x from the string and change it to the character y at a cost of z if there exists any index j such that cost j equal to z, original j equal to x, and the changed j equal to y. Return the minimum cost to convert the string source to the string target using any number of operations. If it is not possible, return -1. Note that there may exist indices I, j such that original equal to this and changed j is equal to changed I. There may exist indices. It just means it's the same. This is also the same. So basically, what we need to do is to create a graph first, right? A to B, B to C, C to B. It is single, right? It's a single, what's it called? Not bidirectional, right? It's a directed, it's a DAG. Oh, actually, I'm not sure if it's a DAG. Yeah, it doesn't really matter, but because the change is only one direction. It's just a one to one, right? A to B, right? In this case, we have A to B have 2. All right, A to B is 2. B to C is 5. And C to B is 5. And C to E is 1. E to B is 2. And D to E is 20. Now we need to change A, B, C, D into A, C, B, E. So to make this change, now the thing is, you cannot say that we just make one change, right? Because, well, if it's the same, then definitely we do not change. So this is the same, so we do not change, so we don't have to consider this part. All right, so basically it's a BCD change to CBE. Now from B to C, right, we can go directly, but there is a graph. So we have A to B, B to C, and C go back to B, and C can go to E, E can go to B, and D can go to E. Right? Basically, we have this graph, and we require a change from B to C. Now, B to C, we can have a direct, or, I mean, this one doesn't really have any, but there may be a path, a different path from going from B to C. So that's what we need to find, right? That's what we need to find. And this also means it is going to be a Dijkstra, right? Basically, what we're asking is from B to C, what is the shortest path, or what is the path with the least cost? And from C to B, what is the shortest? From D to E, what is the shortest? So we need to run Dijkstra for every single change, depending on how many we're looking for. And we're talking about 10 to the 5th, okay? 10 to the 5th. But the cost and the change array is short. So for everything, we run Dijkstra. Dijkstra is, I don't remember what's the Dijkstra, but because this is 2000, it's not too bad, right? It's not too that. And as we go through, they say some of them might be the same, which means we should update, right? The graph needs to be updated. So it has to be a map to a map, okay? And then we run Dijkstra for every single one of them, which may be, I don't know, and we can cache as well, right? We can cache. How do we cache? Now, we don't have to because these are all lowercase letters. So I can do a list of list to handle this, right? A list of list. And then what we can do is, again, a list of list to record what's the shortest path, right, from one to the other. That's basically what it is, the shortest path. That's what we want to do. We want to find the shortest path. And if something has been computed before, then we just don't compute it again. And in this case, we require a change from B to C. And B to C, I think the shortest B to C is 5, right? And then we have a C to B. Now that troubles me, because C to B, because C to B can be 5, this is 2, right? C to B can also be C to E and E to B. Like we can go through this. So that's a 3, that's a 28. Okay. So we are pretty sure on the methods. It looks like we're gonna have to write a lot of Dijkstra, which is completely fine. I mean, just practice. If you cannot do it, that's just a skill issue. All right, so let's first build the graph. So the graph, I'll call it like this. Graph, the new int 26 and 26, right? And then we say for int I, so 0. Oh, holy crap. Because I say for this, go to this. Then we have to just go through every single one, and which means it has to be like this, right? Because the first one is the node, the second one. Wait, hold on. That's not right. The graph is not like this. The graph should be like because I need to know the original node, right? The original node, and then it can go to all these nodes, right? And then go to these nodes. Yeah, this is not necessary. That should be fine. Okay, so I smaller than original dot length, I plus. Okay. So what do? We say, and the weight has to be, cost is larger than 0. So we say graph original I minus A, right? So the graph of this changed I minus A shall equal to cost I. Okay, so this is the graph. So now we need a private Dijkstra. So int Dijkstra. We need a graph. We need a root, and we need we call it source and target. I want to find the shortest distance, right? So basically we say the purpose of this is find the lowest cost, okay? Lowest cost from source to target, right? That's what we want to do. Okay, so Dijkstra. First things first, I need to create weights to to reach these. So weights shall equal to new int 26 because I have 26 nodes, and then we say arrays.fill weights with integer dot max value. Okay, because it's 10 to the 6, right? 10 to the 6, and it should not overflow. So this is the weights, and then we say weights source shall equal to 0 because that's what we start, right? And then I need priority queue. What do I put in priority queue? I think usually we put this because I need the weight and I also need the node. Queue equal to new priority queue. I believe constructor we need to provide AB integer dot compare. I say A1 B1, okay, because I want element shall equal to node and weight cost current accumulate ACC cost. Okay, and I realize weight is not a good way to say. I should say costs, right? I should say costs, and this will go costs. Oh, costs as well. Okay, so I have a priority queue. Next thing is queue.add new int source and 0. Okay, and say while queue is empty, right? If queue is not empty, right? If queue is not empty, and I shall say pop the first one out. So int element equal to queue dot pull, right? Then we say if element 1 is not equal to, or is larger or equal to, no, it's just not equal to costs element 0, then I continue. Otherwise, I pop it out, right? And then I say if element 0 is equal to target, okay, then I will break, right? I will break. Now I will return element 1. Okay, this is the cost. Otherwise, okay, otherwise element 0 is not equal to target, and then I see the problem, because you might go to, actually no, it is right, because the first thing you go is always the lowest cost, right? If I can go multiple ways to reach a target, which can result in lower cost compared to go directly to it, that will be the way to go. So still, the first time you hit an element will be the lowest cost, right? So return element. Otherwise, you have to go to the graph. So we should say for int child equal to 0, child smaller than 26, child plus plus, right? So we have all the child. Then what I will do is I go to graph, right? And I see if that child has a cost, right? Then we say if graph source child is larger than 0, right? Larger than 0, then we have something. Then I say int accumulated cost shall equal to element 1 plus graph source child, right? And then we say if accumulated cost is smaller than costs to reach child, right? if that's the case, then what we shall do is costs child shall equal to accumulated cost and q.add new int reaching child with accumulated cost. Right? So we go through this, blah, 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 blah. We go through all of them and update the costs, and then we just keep going, keep going, keep going. If nothing gets our return -1. All right, so now I have done this. The next thing I need to do is I say int res is equal to 0. Oh, shoot. It's a long. Damn, man. Holy crap. All right, this is a long. Damn. Okay, so everything has to be long then. Okay, long dot max value. Cost has to be long. It's not integers. It should be long. Long. Yeah, all the int. Yeah, I think just basically all the int has to be long, right? No, this is fine. Yeah, this has to be long. This has to be long. Command long to int. Element, because it's a long. But costs. Alright, so we have to convert this to int. Okay, so now this one will return a long. Okay, then we'll say for int I 0 I smaller than source dot length I plus if source dot char I is not equal to target dot char I, right? Then we say res plus equal to long what cost c shall equal to Dijkstra graph. Source is gonna be, it's an int. So I didn't even. Okay, so basically source dot char I minus a and target dot char I minus a. If c is smaller than 0, then we'll return. Then we will return -1, right? Because they say if it's not possible, it should be -1. If it is possible, then res plus equal to c. And we keep going. At the end, we'll return res. Okay, let's give this a shot. Take a look. See if it works. So I just go the easy one and see if it works. Okay, that does not work. I go on to get 30, which is absolutely not right. But the Dijkstra doesn't work. Well, I am going from it's basically C to B, right? Because C to B, I'm polling. Right, I'm polling. I said compare this, and I put the accumulated cost, right? So this one shall get out first. The one shall get out first. It's interesting. That is very interesting. I guess for this I need to check. Let's say system.out.println what collections, I know .toString Or maybe I can just go q.toString. Not sure if it's gonna work. Or it will just print out. Yeah, it's not gonna work. Well, how about we do here? Can say element.toString. Probably can do that. No, what? All right, let's do say string dot format %d element 0 element 1. How about this? All right, I probably should also note when this one's called. System.out.println Dijkstra called the string.format Dijkstra called no, I just call source equal to target equal to source and target. Okay, so the first is B to C, and then I have this and this done. Second one is C to B, so I start with C, right? And from C, the next come out is this, E, right? And wait, hold a second. Right, so now is 4, 1, right? 4, I have 1, 4 and 1. And then from E has only one. E can only go, wait, hold a second. I'm at, oh, you look great. I am at E, right? I am at E. I mean, 0 equal to target, this doesn't equal, so for child, so E could have many child. And then for graph, oh, this is not source. Okay. I find the error. The error is here. This is not source. My bad. This is element 0. Right? It is element 0 because for child, oh. Okay, so int node 0 int cost so now I can, oh, I cannot do cost, but I have costs. Wait, where are the costs? Wait, what is this costs? Cost is this, so I probably should, yeah, let's call long C. Okay, so I have node and C, and here I can do, you know, node, right? Costs node, and element 1 is C, right? If C is not equal to, if node is equal to, then we'll return C, right? And then for child, so this is going to be node child, and this is going to be C plus node child. Okay, let's try this. All right, this one's right. Let's move with all the others and take a look, see if everything is right. Looks good, right? It looks good. Okay, let's write our comment. It's 2976. Create a directed and weighted graph from all. Oh, there's one more thing we need to do. Yep, one more thing. From all the letters, right? From original, right? Original to changed. Then run Dijkstra to find the lowest cost to go from a letter in source to an altered letter in target. Well, it's going to be n is the source, and then times Dijkstra times what Dijkstra is. That's the most 26, right? I think that should be the runtime. But there's one thing. This is not right. Okay, this shall be the minimum. All right, it shall be the minimum. So basically, I shall say, yeah, this is a little bit more complicated. That's a little bit more complicated than what we are thinking of before. So, if, right, if, int o, oh my god, m, let's call m original, o letter equal to, let's delete this. Okay, int changed letter equal to, okay, and then we say if graph original letter changed letter is equal to 0, right? Then this works. Right, this works. Original letter and change letter. Else, okay, if it's not, then graph original letter change letter shall equal to math.minimum graph original letter change letter cost I. This is very important because we can have duplicates. Okay, we're gonna run this one more time. Then we're gonna submit. Shoot, I forgot. Yeah, I forgot to cache it. Ah, my goodness. I was talking about caching earlier, but I just simply forgot. Yeah, that's fine. And then the Dijkstra is not n times 26. Right? It's not n times 26. Well, it technically it is. It's just it's gonna be long, so we can just say long. Yeah, long. I'll call it cache. New long 26, right? And then we say, oh my goodness, source dot char I minus a. All right, change the letter equal to target. Oh, I should say s. I should say t. All right. Dot char I minus a. Okay. Then this one should be SL if this is not equal to TL. If cache SL TL is equal to 0, then we shall do then we shall do cache SL TL equal to this, right? We do this, then we say if cache is smaller than we otherwise will plus equal to cache. Alright, and don't forget to cache. Very important. Alright, let's try the one with cache. Lordy. Holy crap. Well, this to this, this to this, yeah. Let's try again. Hopefully with cache, it'll run faster. Yeah, it runs faster. Submit now. And we pass. A little bit slow, but yeah, it works. I don't know, is it n times 26? I thought it is. Like, what's the runtime of Dijkstra? Yeah, you go through 26 times. I mean, technically 26 log 26, right? I think it should still be on. I don't know. But you have to go through this. This is n, right? And each one you run Dijkstra. You go every single time, and each time you run Dijkstra. And each time you run Dijkstra. And it doesn't really matter what you run because, well, I guess it's 26 times 26. I guess it should be 26 times 26 because the worst case scenario is you have all the different varieties to go through. Yeah, it's Dijkstra. Oh, let's see how long. Yeah, it's gonna be long. M plus n. Loop over the contents. And it's the, yeah. Ah, Floyd-Warshall. Oh, I forgot Floyd-Warshall. Oh. Really? This is a problem asked by Atlassian. It's doable. It took me about half an hour. And I'm using Java. Alright, I forgot. Floyd-Warshall. All pairs shortest. Multi-source shortest path. Effective dynamic programming technique. Calculate the minimum cost path between all pairs of vertices in a directed graph. That's exactly what we want. By iterating through each vertex as a potential. You know what? We have to keep this because it's past half an hour. So I'll have to keep this and then try this another time. You know what? I'll read through this, marinate it, and then it will help us learn. Through each vertex as a potential intermediate point for all pairs, we create a min cost where this represents the min cost to travel from I to j. 3 nested loops to update by considering whether the shorter path exists through an intermediate vertex k. After completing these iterations, min cost will hold the minimum cost for all We enter it through the source and yeah. Okay, is the character being considered as an intermediate? For each fixed k, the inner loop iterates all pairs of character, where ing as source and destination. For each ij, we check whether the current non-minimum cost can be improved by going through the intermediate character k. If it can, we update. So we check. If it cannot, then we don't update. Really? That would be very, very... That make things a lot easier. Wow. I did not know this one. All right, something to deal with tomorrow. All right, that'll be it for today. I'll see you guys tomorrow. Adios.